According to the National Electrical Code, any receptacle that supplies power to a bathroom or any other wet location must be protected by a ground fault circuit interrupter. Since the NEMA 4 enclosure is an outdoor location that is likely to be exposed to moisture, it should be considered a wet location. Therefore, the uninterruptible power supply, or UPS, needs to be protected by a ground fault circuit interrupter. The NEC does not require ground fault circuit interrupter protection for air conditioners or heaters. However, it is recommended that they be installed on a dedicated circuit to avoid overloading. Now let's delve into the details and expand on these points. Firstly, let's clarify what a ground fault circuit interrupter is and why it's crucial for safety, especially in wet locations. A ground fault circuit interrupter is a device designed to protect people from electrical shock. It works by monitoring the current flowing through a circuit. If it detects that some of the current is leaking to ground, which could happen if someone touches a live wire or if there's a fault in the wiring, it quickly cuts off the power. This happens much faster than a typical circuit breaker would react, often within milliseconds, significantly reducing the risk of serious injury or death. The NEC mandates ground fault circuit interrupter protection in areas where there's a high risk of electric shock, such as bathrooms, kitchens, outdoor receptacles, and construction sites. The rationale behind this requirement is to minimize the potential for current to flow through a person to the ground. In the context of the question, the NEMA 4 enclosure presents a unique situation. NEMA 4 enclosures are designed to be watertight and dust-tight, making them suitable for outdoor use and environments where they might be exposed to rain, splashing water, or other forms of moisture. Because of this potential exposure to moisture, the NEC considers the area around the enclosure to be a wet location. Therefore, any receptacles within the enclosure that provide power to equipment like a computer, monitor, or the UPS itself must be ground fault circuit interrupter protected. The purpose of the uninterruptible power supply is to provide backup power to the computer and monitor in the event of a power outage. These devices are critical for maintaining operations and preventing data loss. Because the UPS is connected to a receptacle within the NEMA 4 enclosure, it falls under the ground fault circuit interrupter protection requirement for wet locations. This means that the receptacle providing power to the UPS must be a ground fault circuit interrupter protected receptacle or be fed from a ground fault circuit interrupter circuit breaker. Secondly, let's address why air conditioners and heaters are typically not required to have ground fault circuit interrupter protection under the NEC. While the NEC mandates ground fault circuit interrupter protection in many locations, it does not generally require it for permanently installed air conditioners or heaters. This is not to say that ground fault circuit interrupter protection is not beneficial for these devices, but the NEC reasoning takes into account several factors. One key factor is that air conditioners and heaters are often hardwired, meaning they are directly connected to the electrical system without a plug and receptacle. Hardwired connections are generally considered safer because they eliminate the potential for moisture to enter the connection point, which is a common cause of ground faults. Furthermore, air conditioners and heaters often have their own internal safety mechanisms, such as thermal overload protection, which helps to prevent overheating and electrical faults. These mechanisms, combined with proper grounding and bonding, are typically considered sufficient to protect against electrical hazards. The NEC also recognizes that nuisance stripping of ground fault circuit interrupters can be problematic. Air conditioners and heaters, especially larger units, can draw significant amounts of current, and the sudden surge of current when they start up can sometimes cause ground fault circuit interrupters to trip unnecessarily. While modern ground fault circuit interrupters are designed to minimize nuisance tripping, it can still occur, especially in older installations or with certain types of equipment. Despite the lack of a mandatory ground fault circuit interrupter requirement, it is still a good practice to install air conditioners and heaters on dedicated circuits. This means that each device has its own circuit breaker and wiring run directly back to the electrical panel. Dedicated circuits help to prevent overloading the circuit, which can cause the breaker to trip or even lead to a fire. Overloading can occur when multiple devices on the same circuit draw more current than the circuit is designed to handle. By providing a dedicated circuit, you ensure that the air conditioner or heater has enough power to operate safely and efficiently. In summary, the key takeaways are as follows. 1. The UPS within the NEM 4 enclosure must be ground fault circuit interrupter protected because the enclosure is considered a wet location. 2. Air conditioners and heaters are generally not required to have ground fault circuit interrupter protection, but it is still a good practice to install them on dedicated circuits. 3. Always follow the NEC and local electrical codes to ensure the safety of electrical installations. 4. When in doubt, consult with a qualified electrician to determine the best course of action. Furthermore, let's dive into some additional considerations for electrical safety in similar scenarios. It is important to note that the specific requirements of the NEC can vary depending on the edition of the code that is in effect in your jurisdiction. Electrical codes are updated regularly to reflect changes in technology and best practices, so it is essential to stay current with the latest requirements. It is also important to consider any local amendments to the NEC that may be in place. Local jurisdictions often have the authority to modify the NEC to address specific needs or concerns within their area. These amendments can be more stringent than the NEC requirements, so it is crucial to be aware of them. When installing ground fault circuit interrupters, it is important to select the correct type of ground fault circuit interrupter for the application. There are different classes of ground fault circuit interrupters designed for different purposes. For example, classic ground fault circuit interrupters are designed to protect people from electrical shock and are typically used in residential and commercial settings. Class B ground fault circuit interrupters are designed to protect equipment and are typically used in industrial settings. It is also important to test ground fault circuit interrupters regularly to ensure that they are functioning properly. Most ground fault circuit interrupters have a test button that can be used to simulate a ground fault and verify that the device trips as expected. It is recommended to test ground fault circuit interrupters at least once a month. In addition to ground fault circuit interrupter protection, it is also important to ensure that all electrical equipment is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. All metal enclosures and equipment should be grounded using a grounding conductor that is sized appropriately for the circuit. It is also important to ensure that all electrical connections are tight and secure. Loose connections can create resistance, which can lead to overheating and electrical fires. Regularly inspect electrical connections and tighten any that are loose. Another important aspect of electrical safety is proper wiring practices. Use the correct size and type of wire for the application and follow all wiring guidelines specified in the NEC. Avoid overloading circuits and never use extension cords as a substitute for permanent wiring. Extension cords are intended for temporary use only and can be a fire hazard if used improperly. When working on electrical equipment, always disconnect the power before starting any work. Use a voltage tester to verify that the power is off before touching any wires or components. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Electricity can be dangerous, and it is always better to be safe than sorry. Furthermore, let's discuss some advanced topics related to ground fault circuit interrupter protection and electrical safety. One important consideration is the use of arc fault circuit interrupters or arc fault circuit interrupters. Arc fault circuit interrupters are designed to detect arc faults, which are a common cause of electrical fires. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby materials. Arc fault circuit interrupters are required in many areas of the home, such as bedrooms, living rooms, and dining rooms. They are not typically required for air conditioners or heaters, but they can provide an added layer of protection against electrical fires. Another important topic is surge protection. Electrical surges can damage sensitive electronic equipment, such as computers, monitors, and UPS. Surges can be caused by lightning strikes, power outages, or other electrical disturbances. Surge protectors are designed to protect equipment from surges by diverting the excess voltage to ground. It is recommended to use surge protectors for all electronic equipment, especially equipment that is critical for business operations. In addition to surge protection, it is also important to have a properly sized and installed grounding system. A good grounding system provides a low impedance path for fault current to flow back to the source, which helps to trip the circuit breaker and prevent electrical shock. The grounding system should be inspected regularly to ensure that it is in good condition. It is also important to have a written electrical safety program in place. The electrical safety program should outline the procedures for working safely with electricity, including lockout/tagout procedures, personal protective equipment requirements, and emergency response procedures. All employees who work with electricity should be trained in the electrical safety program. Another important consideration is the use of thermal imaging cameras to detect hot spots in electrical equipment. Thermal imaging cameras can detect areas of elevated temperature, which can indicate loose connections, overloaded circuits, or other electrical problems. Regularly inspecting electrical equipment with a thermal imaging camera can help to identify and correct problems before they lead to failures or fires. Let's also address some common misconceptions about ground fault circuit interrupter protection. One common misconception is that ground fault circuit interrupters protect against overloads. Ground fault circuit interrupters are designed to protect against ground faults, not overloads. Overloads are caused by drawing too much current through a circuit, which can cause the circuit breaker to trip. Ground fault circuit interrupters do not trip on overloads. Another common misconception is that ground fault circuit interrupters are only needed in wet locations. While ground fault circuit interrupters are required in wet locations, they can also provide valuable protection in other areas of the home or workplace. Ground fault circuit interrupters can protect against electrical shock in any situation where there is a potential for current to flow through a person to the ground. It is also important to understand the difference between ground fault circuit interrupters and ground fault equipment protection devices, or ground fault equipment protection devices. Ground fault circuit interrupters are designed to protect people from electrical shock, while ground fault equipment protection devices are designed to protect equipment from damage. Ground fault equipment protection devices typically trip at a higher current level than ground fault circuit interrupters, allowing them to protect equipment from damage without causing nuisance tripping. Finally, let's emphasize the importance of staying informed about electrical safety. Electrical codes and standards are constantly evolving, so it is important to stay up to date on the latest requirements. Attend training courses, read industry publications, and consult with qualified electricians to stay informed about electrical safety best practices. By following these guidelines and staying informed, you can help to ensure the safety of yourself, your employees, and your equipment. Electrical safety is a critical aspect of any business or home, and it should be taken seriously. Remember, the NEMA 4 enclosure likely necessitates ground fault circuit interrupter protection for its internal receptacles. Air conditioners and heaters typically require dedicated circuits. Continuous learning and adherence to codes are essential for electrical safety.